So let's move on to the next question, guys. We have to find out of all these 5 given options, 1, 2, 3, 4, 5, single segment of finite length, right? So these are the 5 given options, right? So let's take the first one. For example, if x to the power 4 is greater than equal to 1, right? What does single segment of finite length means? That the solution set, meaning the value of x which satisfies these equations, right? They should be of finite length. For example, they can be 3 solutions or 2 solutions or 4 solutions, some finite number of values, okay? So now x to the power 4 is greater than 1. If you just don't pick up your pen, you just think mentally. For example, if you take x to be 2, right? So 2 to the power 4 becomes 16. 16 is greater than equal to 1? Absolutely right. If you take x equals to 3, then also it's true. If you take x equals to 4, it's still true. 4, 5, 6, 7, 8, 9, 10, whatever value you take, this will always be true, right? For even if you take infinity, like if you go from +1 to plus infinity, for all those values, this will be true. Now, come back to minus infinity. For example, if you take -2, so -2 to the power 4 is again 16, right? Which is greater than equal to 1. So this is true. If you take -10, it's still true. -100, true. Minus infinity, true. So this thing is true for numbers from minus infinity to plus infinity, right? Barring a few numbers, for example, maybe 0, right? There can be 0, or for any number between -1 to 1, apart from that, or any number you take, -2, -3, -4, -100, +2, +3, +4, +100, plus infinity, this will always be true. So this cannot be the answer, because we are looking for finite length, a finite number of solutions, but this has infinitely many solutions, so this is not possible, right? So I hope this is clear. Now let's come to the next one. X cube is less than equal to 27, right? Now, for example, if you take 3 over here, right? So 3 3s are 9, 9 3s are 27. So 27 is, so this is for x equals to 3, this is absolutely right. If you take x equals to 4, so 4 4 is a 16, 16 4 is a 64. 64 is less than equal to 27? No. So for any value greater than 3, this is not possible, right? But for any value less than 3, it's possible. For example, if you take x is equals to 2, then 2 to the 4, 4 to the 8. Absolutely right. If you take x equals to 0, then 0 less than 27. Absolutely right. If you take x equals to -100, right? So -100 to the power 3, which is 6 zeros, like uh, which is -1000000, basically, right? So even this is less than 27, so this is also true, right? If you take minus infinity, then minus infinity to the power 3 will also be less than 27. So even in this case, there are no bounds, because you can go from 3 to minus infinity. You can go from 3 to minus infinity, and it will still be, valid for all these cases. So there is no finite length, because we can go up till minus infinity, because it satisfies that. So this is also not possible. I hope this is clear, right? Okay. Now, let's take x square is greater than equal to 16, right? Similarly, in this case, if you take x equals to 4, 16 is greater than equal to 16, satisfies. If you take x equal to 5, it will satisfy. X equal to 6, it will satisfy. If you go to plus infinity, it will satisfy. For example, 1 million square obviously will be greater than equal to 16. So for any value greater than, for example, 4, right? Or even a negative, for example, -4 satisfies. -100 also satisfies. So again, in this also, the bound there is no bound, it's boundless, like you can go till infinity or minus infinity. So this is also not an option, right? Okay, now let's talk about this case. Mod of x is less than equal to 2 and 5, right? This is the case. Now just tell me one thing. If you draw a number line and if you draw over here -2, right? Let's suppose -5 actually. -2, 0, 2, 5, right? So if you take any value over here, it can be -3. For example, mod of -3 is 3 and 3 is between 2 and 5. It is true. If you take -4, so mod of -4 is 4 and 4 is between 2 and 5. So basically any value you take between -2 and -5, the mod of that value will satisfy this, right? So this is a solution set, this part. Similarly, any value between 2 and 5 will obviously satisfy 2.1, 2.2, 3, 4, whatever. So any value over here between 2 and 5 will satisfy. So this is also a solution set, right? So there are two solution sets in this, but we were asked a single segment, not two. We were asked for a single segment. So even this cannot be an answer. I hope this is clear, right? Okay. Now, so obviously only one option is left, right? So this is going to be the answer. But how? Let's see. So now it's given that 3x plus 4 is less than equal to 6 is greater than equal to 2, right? So let's just solve this. Let's subtract 4 from all the sides. So 3x is greater than equal to 2 minus 4 is -2. So basically we are subtracting -4 on all the parts. So 2 minus 4 is -2, 3x plus 4 minus 4 is 3x, and 6 minus 4 is 2, right? Now let's divide 3 on all the parts. So -2 by 3 is greater than equal to x is greater than equal to 2 by 3, right? So this is the solution that we are getting. So for example, this is a number line. This is -2 by 3 and this is 2 by 3. So we have the value of x between -2 by 3 and 2 by 3. So basically this is the solution set. So this is only one solution set, a single segment of finite length, which is this much. So your answer is this. I hope this is clear.